Hey everyone, right up here. Cool, so who here has used Gatsby before? Cool, like 25%, not bad. Yeah, so I'm gonna give a talk on some stuff about Gatsby specific, and then also just kind of web performance in general. So the idea is, there's some good takeaways you can take for whatever you're building to make it faster. So first, name's Kyle Mathews, and you follow me on Twitter if you want to. Gatsbyjs.org, blazing fast static site generator for React. If you like Gatsby or want to learn more, I'll be doing training in a few weeks here in San Francisco and in May in New York City. So you can go to workshop.me and sign up. So the origin story for Gatsby is I was building a web app. This was back in 2014 for a startup I was working on at the time. And I wanted to use the same stack for our website as I was for the web app that was simple to use and deploy. And so from that, I was like, oh, OK, we can make like a static generator sort of thing with React. And then I open sourced the first version of Gatsby in 2015. And then after I quit the startup, I went full time on it in 2016, like mid-2016. So I've been working full time on Gatsby for the last year and a half or so. And then we did a 1.0 release in July of last year. And yeah, things have been growing really nicely. We're up to like 20,000 stars on GitHub, 450-ish NPM downloads per month, and around 700 GitHub contributors, which is really great to see. Everyone that kind of jumps in with fixes and improvements and so forth. And really kind of drives my interest in Gatsby. I've always been really obsessed with website speed. It's kind of like a fun game, like how fast can you make this thing go? And it's interesting how there's a lot of ways to make things faster the more you dig into stuff. And so I kind of see Gatsby as a way that kind of gives these same performance benefits to everyone that you don't have to like come up with them yourself. It kind of wraps it all up in the tool. So why is site speed so important? It's kind of obvious. If your site is slow, people don't like it, and they leave. So if you care about people visiting your site and using your stuff, you should make it fast. Studies back it up. 53% of mobile site visits are abandoned if pages take longer than 3 seconds to load, which is actually pretty fast. So if you're some sort of site and your mobile site specifically takes longer than 3 seconds, you're losing a lot of people. Same thing, like 5 seconds to 19 seconds, way fewer ad views, much longer average sessions for faster sites, much lower bounce rates, so on. So there's a lot of great stuff that come from your sites not sucking. So how to think and measure performance. So before you can solve a problem, you have to understand and have a good way of thinking about the problem. Because if you don't know how to think about the problem, you'll never actually solve it. So there are two kind of main metrics that I suggest everyone kind of really pay attention to when you're trying to examine how good is my site's performance, and when you're identifying ways to improve it. So those two are speed index and time to interactive. And webpagetest.org is an amazing free tool that all of you should actually, if you're bored at all in this talk, just open up your laptop and start running this test against it. It's just go to webpagetest.org and test your sites using the simple testing tab, and you'll learn a ton from it. And it should be something. With Gatsby, I've run probably hundreds, if not thousands, of tests on webpagetest.org now. There's also Lighthouse Audit, which is also pretty popular. It's good, but I like webpagetest.org better. Lighthouse Audit is nice because it gives you a nice score from 0 to 100, so it's useful for convincing your boss to give you time to work on performance. But I find webpagetest.org is, when you're in the ditches, and trying to figure out what's going on and improve stuff, that's better. So the basic pattern for identifying or for improving performance is you measure, identify the lowest hanging fruit to fix, and then make the fix, and then measure it to make sure you've actually fixed it, and then repeat. So speed index. Speed index is a synthetic measure. This is kind of the technical definition. It's basically tools that measure speed index. they measure like every 100 milliseconds or something like that as the page loads. And then once it gets to the end, they can like chart how long it took for different parts of the page to come onto the screen. And then they kind of turn that into a one number that's like your speed index score. So I ran speed index on a few common sites and came up with some numbers. So this is on webpagetest.org. So CNN.com, you have a speed index of 8,098. And you can see down below that these are the screenshots of the site as it's loading. This is on mobile. And around 6.5 seconds, you have your first pixels on the screen. And for the next second and a half, you're not seeing much, just a little red box. Kind of abstract art, I guess. Anyways, and then most of it pops in around 8.5 seconds, but it fully finishes at 10 seconds. And so because you have some pixels around 6.5 seconds that are showing something's happening, anyways, the total speed index comes out at 8,098. And so this is a visual progress score. So same sort of thing, 6.5 seconds, it pops up to a little bit of visual stuff on the screen, and then most of it comes in later at a bit after 8 seconds. So Downy.com, speed index quite a bit faster at 5,500. And then they actually have pixels on the screen at 3 seconds, which is twice as fast as CNN. And then they do this kind of weird, well, as we see here, like 5.5 seconds, like they lose part of the screen, and then it comes back a bit later. Not entirely sure what's happening there. You can see it there at like 5.5 seconds over on the right. They lose, it's probably the fonts popping in or something. Anyways, yeah, so WashingtonPost.com, they're at 7,600 seconds, and yeah, they also lose like their own ad. Oh, it's like a video or something. They have like a placeholder image or something, and then the video starts loading, they lose the placeholder image. But anyways, kind of bouncing up and down again. Cool, and then gatsbyjs.org, let's see how it does. Hey, whoa, not bad. Yeah, 2,300 seconds, nice. And yeah, I like the chart too. It's like, just, it starts and then it's done. So knows where it's going and it just gets there. Cool, so that's speed index. It's super useful. It just gives you a one number, pretty good representation of pixels coming onto the screen and how fast that is. And it's very easy to compare from different changes you're making and like over time. So it's a very useful number. The next one is time to interactive. And I somewhat jokingly call that the silent killer, because first interactive is when your page is minimally interactive to user input. And it's not as obvious as speed index, because if your speed index is slow, you just don't see anything. But if your time to interactive is slow, then your users are kind of like trying to click on things and type on things, and nothing's happening. And it's super irritating. But it's not as obvious if you're just casually loading the site and looking at things. So yeah, so before interactivity, scrolling is janky, typing forms of interactivity is hard. And yeah, some of these sites do a really poor job. Washington Post takes 33 seconds. Oh, actually, I must have taken it. No, anyways. Yeah, and the others weren't, this is the worst, but the others weren't too great either. Cool, so how do you improve performance? You improve your speed index by optimizing for the critical render path. Google has a great article that goes into a ton of detail on this, and highly recommended reading. So very quick summary of that is, avoid any work or loading of data that's not required to get your pixels on the screen. And so speedindextest.org, again, has like a really nice, has a lot of tooling to kind of like help you see what's loading and when. And so you can say like, oh, that's not needed till later, and then you can delay it. So stuff like that. Yep. Okay. Yeah, and TTI, so time to interactivity is mainly affected by how much JavaScript you're loading. So the main way to improve your TTI is just load less JavaScript. And the main way to do that is code splitting, which is a whole talk by itself. Or actually, it used to be. I'm going to get to later. Webpack 4 has some really nice stuff that I'll get to later that make code splitting a lot simpler. But yeah, so don't create one JavaScript bundle that has all the JavaScript for your entire application, your entire site, but try to figure out what is the JavaScript necessary for this one page and load that, and then lazy load in JavaScript for other parts of it as needed. Yeah, so, and I think it's important that to remember that this is kind of a journey and a kind of an ongoing concern. I mean, you can put some targeted effort into improving performance and make a lot of impact, but if it's not part of your culture to be measuring this stuff and paying attention to this stuff, then performance regressions are easy to slip in. So a few ideas that a lot of people have found helpful for kind of encouraging a good culture of performance. There's the idea of performance budgets, which is how much JavaScript can we load on these different critical pages, and how much CSS can we load, and stuff like that. And then you can be measuring PRs, and if somebody goes above it, you can be like, oh, OK, we've hit our budget, and we got to cut back somewhere or do something to mitigate the change. It's another great article. There's also a number of performance monitoring services, none of which I've used directly, so I can't say too much. But speedcurve.com is a common one. Get continuous feedback on how your code affects the user's web experience. So stuff like this is great to just be kind of passively monitoring stuff. And a lot of these integrate with GitHub, and so you can kind of get automatic feedback. It's like, hey, you guys got slow, figure it out. Cool, so hop into Gatsby a bit. So why is Gatsby so fast? So Gatsby sites are consistently 2-3x faster than similar types of sites. Done lots of measurements of this. And the reason is that performance is actually really complicated. There's a lot of stuff you have to do right in order for things to be fast. And with Gatsby, that's all built into the framework. It's not, you don't have a choice whether you have good performance or not. It's built in. And so it makes a lot of optimizations automatically for your sites. The basic contract between Gatsby and the creator using Gatsby is you just focus on React components, and then you hand Gatsby the components, and then it compiles those to an optimized site. So it has a lot of built-in optimizations. It identifies the critical CSS for each page and inlines those in the head, which avoids an extra HTTP request. It uses link preload, which is a new browser link, I guess, whatever. Anyways, that category of things. But anyways, that Chrome and Firefox and a few others support, and it kind of tells the browser to start fetching critical resources earlier than it might otherwise do, and it can significantly speed up things. It has a really easy way to get kind of lazy loading images with a Gatsby-specific React component called Gatsby image. It automatically does per route code and data splitting to keep your time to interactive fast. And it also does kind of aggressive prefetching. So if you go to a page and Gatsby has some heuristics to guess what is the next page somebody's going to click on. And so it starts in the background prefetching the data and code for that page. So when it comes time to click on something, it's already there. You just click, and then it's instantaneous. So it feels like you kind of have the whole site there on your computer, but it's actually lazy loading things on demand. Yeah, so the goal is it's not really hard to make a fast site. It's really hard to build a slow site with Gatsby, which is kind of the reverse of the norm. So the PIS success idea, but for performance. Yeah, so let's skip over some things. Yeah, so I think of Gatsby as kind of an early example of what I think will be kind of dominating tools in the future, is that website compilers. So if you've been worked in native code, you know that you write source code, and then depending on where you're shipping your code, there's a compiler which does a lot of optimizations and bundles it up and pushes off to that thing. And the web, as the web gets more and more complex and we do more and more stuff, we're treating it more and more as an app delivery platform. We need compilers now to handle the complexity of moving your app to the user in a performant way. So yeah, so again, you give Gatsby the source code, and it compiles it. And over time, Gatsby is going to get faster and faster. There's a lot of optimizations that we've thought of and just haven't had time to implement, but they're on the roadmap and they're coming. Working actually on V2 right now of Gatsby, which I'll mention some optimizations that are coming with that pretty soon. And this is kind of the same trend that we've been seeing for a while. A lot of people using Babel, a lot of people using Webpack, Sass, PostCSS. And so Gatsby is sort of higher level abstraction, kind of like hides all these things and has like a more opinionated way of how these things should come together. So Tom Dale from the Ember world, he wrote this really nice blog post last fall about compilers of the new frameworks, because Ember is also going down this same path of doing more and more compiler-like things to generate Ember apps. So he wrote, when it comes to eking performance out of hand-authored JavaScript and accompanying runtime libraries, we've reached the point of diminishing returns. Increasingly, the bytes that get shipped to browsers will bear less and less resemblance to the source code that web developers write. The assets we serve to users will be aggressively optimized output of sophisticated build tools. And the trend started by modifiers like Uglify in Babel will only accelerate. So conclusion is performance is really hard. So I suggest using Gatsby, if it fits your use case, of course. Cool. So coming changes in V2. So React 15 to 16, which that and a few other things will drop the default bundle to be around 20%, JavaScript bundle will be 20% smaller. Babel 6 to 7, which is a really nice upgrade. Transpilation speed's a lot faster. One really cool thing it does is now it has automatic polyfilling. So currently in Babel 6, if you want to polyfill, you kind of import one file, and then Babel expands that to all the polyfills necessary for the browsers that you're targeting. But in Babel 7, it'll only polyfill JavaScript features that it detects you're using. So if you use includes, then it'll add at the top of the module or the file the polyfill necessary for that feature, which can lead to a lot of savings. It's a lot more precise. There's also preset environment. How many people use preset environment if you have custom Babel? OK, it's really cool. I'll use that if you're using Babel. But anyways, so there's a new target called ES modules. And this is the PR that added it. And there's kind of this trick, I guess, that there's a new script type called module. And only newer browsers have that. And because they're the only ones that will respect that, you can add 2 script tags, one targeting module and one targeting older browsers. And it allows you to compile a version of your code that's targeting only these newer browsers that support the type module for script tags. Anyways, which is cool because now when you have classes or a lot of other modern JavaScript, you can know that the only people who are going to get that are Chrome and Firefox and so forth, and do a lot less. Anyways, you have to compile a lot less, and the bundles are a lot smaller because of that. Yeah, and we'll probably I need to do some more testing, but I think we can turn this on by default without too much of a performance hit for the build time, which will be really nice. We're also going from Webpack 1 to 4. We shipped Gatsby v1 just after Webpack v2 came out, and then they've been busy doing lots of upgrades. So anyways, a lot of big changes there. So better tree shaking support. Kind of the highlight, though, that I think makes Webpack 4 a must upgrade for everyone is the split chunks plugin. And basically, if you've used Commons Chunks plugin, this is what you kind of hoped it always would do, where it just looks at all your async or your dynamic imports and takes all the chunks that you're across your site and then automatically creates as many common chunks as are necessary. So it'll say hey, of all the chunks, React is using all of them. So we're going to create a bundle that has React and a few other common stuff. And it says hey, these 3 routes have these these modules in common. So we're going to create another commons chunk just for those 3. And anyways, it's actually really, really nice. I've been playing with it for the last few weeks, and it's very impressive. So yeah, definitely recommend upgrading Webpack 4 and enabling that. Another really nice upgrade is Mini CSS Extract plugin, which is a replacement for Extract Text plugin. And yeah, highlight of that is you now have automatic CSS splitting. So all those, when you have split text plugin, all the CSS, all the JavaScript chunks are created. It'll also create CSS chunks for all those. So if you're doing the pattern of importing one CSS file per component, then the CSS is only loaded when you use that component. And Gatsby will actually also inline the critical. So now it enables us to say, for this page, given the components used on that page, we know what CSS is being used, and we can inline that CSS and then lazy load the remainder of it as you browse around the site. So yeah, quick demo of that. So this is a example site, a Gatsby example site that has, it's basically just to demonstrate how to use CSS modules with like post-CSS and Sass. And this is running the alpha, a canary version rather, of Gatsby v2. So if you load it and you're looking at the network, you see it grabs the HTML first, and then it grabs this app bundle, which is like the kind of the commons chunk for the whole site. And then it has the JavaScript chunk for this front page, as well as the CSS chunk. And then Gatsby does kind of like lazy prefetching. So it only prefetches pages where the link is on the screen. So there's some links below this pointing to some other pages. So as we scroll down, and one of the links shows, yeah, it now grabs the CSS file and the component chunk for this next page. So like if we click on that, it's all already loaded. And then clear that again, and we scroll down a bit more. Yeah, and then the second one comes. So there's that. Cool. So yeah, so hope you all use Gatsby and come to my workshop. So, and nice being with you today.